Right, today we are now going to do question 3 of 2008. So we now have a graph y equals to f of x on a certain function. On the next 3 pairs of axes are graphs of these. Say which axes correspond to which graphs. Let us look at the terms beside f of x. This first one corresponds to f minus x. It reflects along the y-axis. Therefore, this y is f of x reflected along the y-axis is b. So let's write here y equals to f of negative x. What about fx minus 1? Fx minus 1 means that the whole thing is shifted by 1 unit to the right. Y equals to fx minus 1. And negative fx is the other one, and it basically reflects the whole thing along the x-axis. So we had negative signs, which are used for reflections. And let's write this down. And a little bit on trivia, the equation y equals to negative f negative x rotates the whole graph 180 degrees around the origin. Sketch on the axes opposite graphs of both the following functions. These functions will look strangely familiar if you know about the Gaussian distribution / bell curve / normal distribution. The reason why it's got so many names is because it's so common in everywhere. So let us label the axes 1, 1, 2, negative 1. So y equals to 2 to the power of negative x squared looks just like y equals to e to the power of negative x squared, just a little bit wider. So this is how I remember graphs. So you could probably use this hack in your exam as well. Let me try drawing a better curve. I know I'm not that good at drawing curves. I still need to work on it. So I'm very sure it will be this way, and then it will probably taper up at about 1/16 here and 1/16 here. And the graph of y equals to 2x minus x squared is the graph of y is 2 to the power of negative x squared translated to the right by 1 and stretched parallel to the y-axis by a factor of 2. Why is this? So let us describe the transformations. So 2x minus x squared equals 2 minus 1, no, 1 minus 1 plus 2x minus x squared equals to 1 minus x squared. So it is stretched parallel to the y-axis by a factor of 2 because the 1 basically multiplies everything by 2. And the 1 minus x means that you have to flip it, which in this case you don't have to do because on the algebra hack which says 1 minus x minus 1 squared. And it's stretched parallel to the y-axis and translated to the right by 1. So this is 2, and so we have to draw it this way. Carefully label any stationary points. The stationary points are 0, 1 and 1, 2. Of course, you cannot do this using calculus as the functions will be too complicated and you have to multiply everything by what is known as my favorite constant, the natural logarithm of 2. You know what? Let's just do it. So dy over dx for the first curve equals to minus 2x times 2 to the power negative x squared times ln 2. Why? We can write this as y equals to 2 to the power of negative ln 2 x squared. So we can use the product rule and move the ln 2 down. And this is actually e. And so let us calculate dy over dx is 0. So it's either 2x equals to 0 or 2 to the power of negative x squared equals to 0. This latter is not possible, so which rules out the only possibility that x equals to 0. Therefore, y equals to 2 to the power of negative 0 squared equals 2 to the power of 0 equals to 1. And if you know your values of indices, you can see why this is so. Let c be a real number and define this following integral. State the value of c for which IC is the largest. So this means that C equals to half. Do you know why it's half? Because if we try plotting a value of area from 0 to 1, it will still look the same because this has the same area as this. So it would probably go from here to here. But no, the area is not constant. This is not a constant curve. So it will probably taper up a bit like this and up a bit. So the graph of 2 to the power negative c minus x minus c squared is the graph of 2 to the power negative x squared translated c to the right. This integral represents what's called the sine area. Basically, in your graphs over the x-axis, you can just ignore the sign. So as the graph is symmetrical around its maximum point, therefore c must be half. You know what? And if you are the kind of maths junkie who says, no, I don't want this, I want the area. Well, I don't know the area under a Gaussian bell curve, so you could probably check it up in your university math textbook. And I'm very sure, I bet you it will possibly involve the error function times the square root of pi. And the square root of pi. Well, and I bet you that the formula will also include log 2. So if you have a value for this area when c equals to half, send it to me, and I will probably cover that in my next deriving formulas. See you!